Today we're studying Chapter 4, Section 3. In this section, we're going to learn how to graph a quadratic function using transformations. And then we learn how to identify the vertex and axis of symmetry of a quadratic function. And then graph quadratic function using its vertex, axis of symmetry, and intercepts. And then we want to find a quadratic function given its vertex and one other point. Finally, we're going to learn how to find a maximum or minimum value of a quadratic function. So let's look at the definition first. What is considered to be a quadratic function? Quadratic function can write into its standard form. F of x equals ax squared plus bx plus c, where a, b, c are real numbers and leading coefficient a is not equal to 0. Okay, so a, b, and c, they are called coefficients. Okay, they are all the coefficients. So what is a coefficient? They are numerical number of each term. Okay, so not including the variable x. Okay, so when you identify the coefficients, make sure they're only numerical values. Okay, no any variable involved. So quadratic function doesn't have a denominator, doesn't have even index roots. Therefore, the domain of quadratic function is the sets of all real number. Okay, what about the range? Range of quadratic function is a set of non-negative number, okay, which is from 0 to positive infinity. Okay, we will see that from the graph later. So now let's look at the data table. So what kind of model this data is? Okay, let's check. Okay, see whether it's a linear or quadratic or exponential. Okay, let's see. So let's look at the x coordinates. So every x is like an increase by 5, right? What about the y? From 12,000 down to 11,200 is down 750. Right? From 11 to 50 down to 10,500 is also down 550. And then you can try to calculate the rest of it, all down 750. So this kind of data, they have the same constant, right, as rise, and then same constant as run. So that's why this is actually the linear data, isn't it? So they have a constant rate of change. All right, so we say this data is linear. This seems to be right. Missing all the sign. This is a quadratic function, right? Because independent variable has the second power. And then this is x first power term, right? And then no constant term. So it's like at a 0, that's a constant term, right? So that's quadratic function right in standard form. And then if we graph this quadratic function using graphic calculator, you can see there's a parabola. Okay, so the graph for quadratic function is a parabola. All right. So let me talk a little bit about a parabola. Parabola it's like a U-shaped. Okay, it's either open down or open up. Later we're going to learn. Okay, so actually leading coefficient a is controls parabola open up or down. So if a is a negative number like this, okay, a equals negative 150, so parabola open down. Okay, if a is a positive number, parabola will be open up. So in the real life application, what kind of problem is using quadratic function modeling, like the path of projectile? Okay, we shoot a bullet, right, from some certain height, and then this is a cliff in the picture, and then it's the path of this missile or whatever, and then fall, right, due to gravity. So it's a projectile. Okay, it's like you throw something in the air and eventually it will drop right on the floor, and then that is also follow the path of projectile. So that's actually is a quadratic function modeling. Okay, so it's like the complete parabola is like that. Okay, because initial height is not from the ground. Okay, that's why this part I just use the dashed line to represent. Not really exists. So I just want you to see this is a parabola. Okay, that's why I just use the dashed line to represent the other part of parabola you cannot see.